Hello, Julin.
Hi.
Can you hear me?
Nice. Yeah, I can hear you. Right. Thanks.
Yeah, you're audible. Yeah. Okay, so
Yeah,
first,
cool.
thank you for being here for the talk, and I'm going to introduce you to the audience.
Yeah, right.
Hello, everyone. Welcome to session 2 for day 2 of PyCon Indonesia 2020. My name is Zaki, and I will be the moderator for this session, publishing well-formed Python packages by Julin Shaji. Julin is a Python enthusiast who likes to fiddle with text, who has made and published few packages. So for you who wants to publish a package, a well-formed one, this talk is a good spot for you. So first I'm going to add the screen. Okay, cool. Yep. Without further ado, the stage is yours, Julin Shaji. For the participants, you can keep those questions coming on Hopin platform. The moderator's team will collect them and we will discuss it in a Q&A session. Now, let's give a big round virtual applause to Julin Shaji.
Thanks, Aki. Thank you. All right. Hello, everyone. I'm Julin. Welcome to this talk about publishing well-formed packages in Python. So let's get started, shall we? So what is a well-formed package? What does that mean? I mean, what do I mean by that? Well, the primary objective of having a package well-formed is to make its maintenance easier, so that the developers don't have to don't have to find time for fixing problems and that they could have avoided in the first place, or at least minimized in the first place. So it makes so less maintenance means developers can work together, doing more fruitful work, and they can communicate with each other, collaborate together, working on their project, and with less sources of confusion. Such a project would be we can change such a project relative to the changing needs. We can evolve the project because of certain characteristics that makes the package well formed. So how can we make our package well formed? Well, among other things, sufficient documentation and proper test, along with a few related stuff, can help a lot. So let's have a closer look, shall we? And for that, this is an overview of the topics that I intend to cover in this talk, all the way from linting and styling through testing down through packaging and publishing. Let's start with linting and styling. So one of an important and major characteristic of a good code base is a readable code base. So in order for a package to be well formed and in order to be well maintainable, in order to make maintenance easy, we should be able to read and understand it in an easy way. So as they say, code is more often read than it is written. So we need to make the code readable. So how can we make the code readable then? So the good first step would be to adopt a coding style and stick with it, and make use of tools like linting tools to help enforce those practices. This leads to a consistent formatting, which makes collaboration with others easier and also lead to neat, well-formed code. And among other things, such linting tools can also help you uncover subtle bugs that you might have missed, that you would have missed otherwise, only to realize your mistake when the code goes into production, right? So we don't want that to happen. And of course, Pep 8 has a lot of good suggestions, which would be nice to keep in mind when you're writing your packages, when you're creating these packages. But remember that Pep8 itself mentions that its suggestions are are to be considered more as guidelines rather than steadfast, hard and fast rules. So, so there may be occasions where it may be better where it may be better to make exceptions in some cases. For example, consider a very long link. I mean, a link which is longer than the maximum number of characters allowed per line as per the coding style that you're following. Suppose you want to add that link along with your code as a comment so that you can refer to it in case you have any doubts related to the code that you've written. So maybe it is complex or something that you might need help in future because you might forget. So you need an insurance policy, and you inserting that link along with your code as a comment. But unfortunately, the link is too long that the coding style would not allow it. So what would you do? You split the link into 2 lines as into your code. That would, among other things, cause your whatever editor that you're using to stop recognize that as a link, so that you cannot go to that link just by clicking on it. You have to put it back together, paste it, copy it, and whatnot. It involves a lot of trouble. Anyway, it sounds wrong, right? So in such occasions, it is probably best to make an exception to your coding style, whatever coding style that you're following. And most linting tools would allow for to make exceptions. They are configurable, and above that, most of the prominent ones at least, will allow to make exceptions per line. And in some of them, you can add a comment, no CQA, and it will it will not warn about that line. You can do that. So what tools can we use for performing this linting and styling task? Pylint and Flakeit are some of the are among the most prominent linting and styling tools that we have for Python today, and both of them have a very active community growing around them. And so, in case you have any trouble with them, you won't find it hard to find someone to help you out. There are a lot of friendly people in those communities, and you can ask for their help. They'll be more than happy to help you out, I think. And these tools are pretty much configurable so that you can adapt these tools to the code style format of your choosing, so that you can customize the behavior that these linting tools will allow. Pylint especially, which had been around for a very long time, at least 10-15 years, I think, especially is quite famous for having too many configuration options. So you will find a configuration that fits your needs. And then there is Black. Black is an automatic code reformatting tool, which is quite popular these days. So if you're using a linting and styling tool like Pylint and Flakeit, every time some change is made, you will have to run these linting tools and find the problems and fix them line by line. It involves a lot of work, and sometimes it takes too much of your time. This is very easily possible if there's a lot of big community growing around your project, and a lot of pull records are coming in, and a lot of linting and styling mistakes can easily creep in. So taking care of and fixing these mistakes, these errors, can easily take a long time. And but if you're willing to give up control of the fine tuning, the fine details of the code formatting part, you can ask Black to do the code formatting for you. It is not exactly very. Its configurability is limited, but it will format your code such a way that it looks the same no matter no matter in what style the code was written in. Once you apply Black on it, it will appear just the same, no matter how many people wrote that and how many in what all ways they wrote it. After going through Black, it will look just the same. So this is this is the main reason why a lot of projects which have a lot of whose community have a lot of people in it are using Black. So it leads to consistent style with improved readability, you see. And even the tips, if you have tips, the difference will be minimal, because black will take care of the formatting part. So another aspect that can help is static type checking. So as you may be knowing, Python had been having allowing type annotations for variables and functions for quite some time now. So taking advantage, I mean, actually making use of these type annotations in your code can not only improve the readability of your code by letting you know what kind of values these variables expect it to be, you can also sort of take advantage of a sort of a type system in a dynamically typed language as Python. So you can have the best of both worlds, which is of course a good thing, right? And another good thing is that if you're using type annotations, these type annotations themselves would not have any effect on the code itself. I mean, when you run it with or without the type annotation, it will run just the same. There won't be any difference. It won't influence the program execution. It just looks good, and you can also run static type checking tools to see if there are any errors. So some of the prominent type checking tools available in Python for Python is MyPy, PyType, and Pyre. For let's see an example of the advantages offered by type annotations and static type checking. For this example, I'm using MyPy. So we have here a function which accepts two variables x and y and does some comparison on it. So if x is less than y, returns a negative value -1. If x is greater than y, it returns positive 1. And if x and y are the same, it returns 0. Right? So just by looking at it, how do we know what kind of values x and y can be? Maybe the author of this function intended to accept all the kinds of variables which allows comparison operators. Maybe not. So maybe this function can be invoked like this, using two integers as arguments. But it could also be invoked like this, using two lists as arguments. Or like this, using two tuples as arguments. Or like this, among other things, as two strings are arguments. But in this case, I actually meant this function to accept two strings, compare it, and return value. I mean, I created this function to mimic the function strcmp in the C programming language itself. So what I really wanted was the last option. For the string, it accepts two strings as arguments. But just by looking at it, there's no way to say that that's what I intended, right? Unless I, of course, put some comments and some doc strings and stuff like that. But there are easier ways, like this. See, I used type annotations for the arguments and the return value of the function. So it's very clear for looking at it, you can say that x and y are supposed to be strings and returns an integer. And yet, if we use the function like this as two integers itself, Python won't complain, the interpreter won't complain because it will run just the same. But that's not what we intended. We want something like this. We want to see if something like this happens, so we can take care of it, right? So we can run MyPy on it, and it will instantly find us that there's something wrong with its code. A string that we got integers, so we know what's up. So I change those arguments to strings, and MyPy is happy. So that's it. So another thing that actually haunts your a project as it evolves is dead code. As the project grows, it's bound to have some dead code accumulated with it. And this dead code sometimes will stay silent, but other times it can come and interfere with the rest of the code, leading to very unexpected results. So using a tool to identify the presence of dead code and so that they may be removed is a very good idea. So there are many tools. Among them, we have Vultr, PyFlakes, and PyFlakes is included in Pylint itself. Both of these are static tools, so they're static analysis without actually running it, and they're quite useful. Let's see an example. I have here an example that I got from Wikipedia. I have a function foo, which takes two variables, two integers x and y, and returns return its product. But notice that in line 2 I have an extra line which is actually dead code saying z is equal to x by y. Well, it usually don't have any effect on the code on the function. But what if y is 0? The presence of the second line will cause errors. A divide by 0 error will happen. So the presence of dead code can cause such kinds of problems. If you remove it, we're happy, everything's fine. So So it is important to verify that your code, your functions behave as you expect it to behave. Now you may design your functions, you may create everything, you will type it up, you code it, everything may look fine, but may not work as you expect it to work. There may be some border cases, maybe the function may, the general case itself may be wrong. You need to verify it by testing it to ensure that it works as you expect it to work, of course. So in order to do this, organizing your code into different separate testable functions would help, but it's not exactly required. There are other things that can help you work it out. So there are different testing tools and frameworks available for Python. Unit test is a built-in Python module which can be used to perform testing, but it is not exactly as straightforward or beginner-friendly as PyTest. PyTest is the third-party library, but it is very, very popular. I would suggest you to use PyTest instead of unit test, because unless you have to use unit test, PyTest will be better because it is more straightforward, easy to use, easy to learn, beginner-friendly, all of that. So let's see an example of the advantages of having your code tested. In this example, I'm using PyTest for doing the testing. I have the strcmp function again here, so I made a slight modification, but let's see. So I have a test case here which sees if chicken and compares chicken and egg. So we can see that chicken comes before egg in the dictionary, so the return value should be -1. But the test fails. Return 1 instead of -1. Can you figure out what went wrong? I expected it to return -1, but it returned 1 instead. So if I had proceeded thinking that I doesn't need to test, I don't need the test, it works fine, I would have been in deep trouble. So what went wrong here? Let's have a look. So what went wrong? These two lines are what went wrong. I used less than instead of greater than, and greater than instead of less than. Well, that is easy enough to fix. So I fixed it. So I run the test again. Now it passed. So that's the advantage of testing. This is a simple example, but I think you get the idea, I hope. So just doing the testing alone is not sufficient, not at all sufficient actually, because you need to ensure that you test all the relevant parts of the code. So what's the point? So there otherwise there's a little point, because if you test only a little part of it, it would be as good as testing not having any test at all. So you can use a testing. You can do some analysis to do coverage test to see if the test cover have adequate coverage for your code. And running such a test would allow you to spot the parts of code that you missed, so that you can write more test cases to make sure to fix that mistake and have adequate coverage, so that all will be good. Total coverage, 100%, literally 100% coverage would be okay to have, but may not always be worthy of it. I mean, there are some parts of code which is as good as tested. There's no point in testing. Such parts of code can happen. So don't go for literally 100% coverage is my suggestion. But you can, instead of testing some irrelevant parts of code, you can just ignore that. That would be better. So to do the coverage test, you can use coverage.py, which actually runs your code to see which all parts of your code the test missed and all. And there is PyTest Go, which is a plugin for PyTest, which actually makes use of coverage.py. So if you're already using PyTest and would like to have something that integrates more closely with PyTest itself, you could use PyTest Go for coverage tests. So let's see that example of STR symbol again. So as you can see, there is only one test. There are three cases that the strcmp handles. One is when x less than y, other is x greater than y, and other is the else part, where x is equal to y. But have we covered all of it? Of course not. We have covered only the x and y part. X greater than y and equal to y are not considered. Running coverage will tell you that how many missed? Okay, 3 statements have missed, and there is coverage of only 50%. So it will also actually highlight the code that was missed by the test in similar fashion like this. So we saw what the parts of code were missed. So we can easily fix it. Add more test cases so that the two cases are also covered. Also test. And coverage is happening. We have 100% coverage. No statements were missed. And one thing let me bring to your notice about the advantage of using Python. This test case is, though it has 3 assert statements, is actually a single test case. You may want PyTest to treat it as 3 separate tests. You can use a parameterized test like this. In PyTest, it's as easy as having a iterator like this to pass these arguments one by one to the test function. Just like that. It's as simple as that. And it looks quite reliable too compared to the parameterized tests that we can find in some other test frameworks. So we have a your project tested. It works on your computer, on your Python version, on your Python implementations. It's probably C Python. Fine. But that may not be all. Your package, project may be intended to work on other and other environments as well, like a different Python version or a different Python implementation. We have to make sure that our test passes in all such environments. Of course, we could actually do it by hand by going to changing to different Python version one by one, or and different Python implementations like PyPy if you like, one by one. But that's needless, takes too much time, and of course, test automation would be desirable. So we can use a test automation tool for that. And one thing to note is that some features in Python would be available only in some versions, or maybe some characteristics will be available in some Python implementations maybe. So if you're testing only in one or a few or select few of these environments, it may work in that environment, but it may not work in some other environment that you are hoping to support. So it is important to run all these tests in all the environments. You can use tools like Ox and Nox to do that. And I also run more than 5 to 7 test cases. You can run the static type checks, linting checks, everything can be done using these tools. What Ox does is that it creates a separate virtual environment just to run the test of your code, and runs it. Then it creates them and runs it from them as if those packages were installed in a separate virtual environment, so we can get a better idea if it will work better in a fresh installed machine or something. Yeah. Talks saying that the tests have all passed in the environment may not necessarily mean that your tests have actually passed, because of non-decisive configuration, non-decisive layout. So what a package layout means for a Python package is the way the directories and files are organized in the directory of that package. So there are two main commonly used package layouts. One is the SRC layout. One is the flat layout that you see right here, and the other is the SRC layout. In flat layout, you have the source code under the package name directory. You have the source Python files in that directory, and the tests are in the test directory. So as you can see, the source code and the test directories are in the same level. That is to be noted in the case of flat layout. In the case of an SRC layout, the test and the source code directories are separated by another directory. The source code is inside yet another directory, so as to isolate the source code from the test directory. Let's tell you why. In the case of a flat layout, the talk will create a virtual environment for you, as I marked in the bottom right corner. It will install your package, build your package, and install it in the site package directory of the virtual environment that talks created for you, and it means the test in the test directory to import that package from that site packages directory. But because of the way Python import system works, and because of the fact that the source code directory is in the same level as the test directory, it will instead import from the package name directory itself, instead of downloading from the site package directory of the virtual environment that Talks has created. So this has the effect, this negates the advantage that Talk offers you. You are actually running the test in your environment itself. And that may, confuse you and may make Talks think that the test actually worked when it in fact it may not have worked. We can solve this problem by isolating source code and the test directories in like this, as an SRC layout has done. If you do like this, the test cannot import from the source code directory in the package name folder, because it is another one directory inside it. So it is forced to use the packages installed in the virtual environment that Talks created, as in the site packages directory, as I've shown in the diagram. And this is the reason why a lot of people were, we're talking about moving to SRC levels. A lot of projects have already moved. But in the case of small projects, it's probably not necessary. But I think it's a good idea to move to an SRC layout just in case, But that said, there is no officially recommended layout. The Python community have not agreed upon a single recommended layout. So what we can do is choose the one that fits your niche best. If your package is, your project is quite small, and you might be okay with using a flat layout. But if you have sub packages and stuff like that, it is, I think, better to use an SRC layout to avoid future problems. You can refer to these links to see some interesting arguments, or go to the GitHub page for PyPA. You might find some issues and very long arguments. People arguing about which one is better and what are the advantages of this and that. So you might want to check it out. So once your project is, the coding part is complete, you would want to document it, so that others who will use the project will know how to use your project. So they want to know how the project may be used, how these functions are supposed to be called, where these functions are, in what sub packages this function is, what are the function names. These all stuffs that we have to, the creator of the package itself himself would have to tell the users how to use it. Proper doc strings and comments would be helpful, of course. And for small projects, a simple README file may be enough. But that is not always the case. But if you have a lot of, you need a lot of pages of documentation, it is probably a good idea to use a documentation generator like Sphinx, mkdocs, and stuff. Sphinx is what the Python documentation itself that you see in docs.python.org that is created with Sphinx. I think it's actually created, that Sphinx was actually created for that purpose. I need to use restructured text format. Whereas, and it can also accept Markdown, but then you'll be missing out on some pieces of REST language. And Markdown access, I mean, mkdocs will accept Markdown, and it's quite simple, beginner friendly. So once you have your code ready, you have your code ready at this point, right? So once you have everything ready, you will want to share your module with others so that you can share your work with others and use it and tell you about it. Feels good. Yeah. Uh, so what we need is to create a file that can be used to install our module in a different Python, Python system in somewhere, maybe in someone's computer. The process of creating such files is called packaging. So you can create a binary distribution like a wheel file, or a source distribution like like as a source distribution. So there are many tools available now to do the packaging. There is setup tools by PyPA, Python Packaging Authority. This is an older one, and it was for some time it was almost the only one available. Then newer ones came in like Flit and Poetry. Flit and Poetry are quite new, but Poetry has got a lot of followers, a lot of projects have started using it, and it's quite cool actually. So once you have your files that you need to distribute, the wheel file or the source distribution or both, you have created that by packaging using a packaging tool, and now you need to publish it. You need to upload it to some server so that others can download from that server and use it in their own systems. So in the commonly used server is PyPy, okay. But I would suggest you to first upload it to the test.pypi server, which is almost exactly the same as pypi.org server. The way it works, I mean, not the list of packages installed in them, but still. Because it is almost like a playground where you can test things out, whether your package uploaded and downloaded. I mean, you were able to install your package properly from the test.pypi server. You can test all that before uploading to the actual PyPI.org server. So to do the uploading part, uploading the packages, the distribution files that you have created. In the case of setup tools, you can use Twine. Actually, Twine can be used to upload the distribution files irrespective of the packaging tool used. But in the case of Flit and Poetry, they can do the publishing part on their own. And I mentioned a lot of tools in this talk, but there are countless other tools that we can use. Of course, you need not use all of them, but use your judgment and pick the things that you want, that you think that would be useful to you, and get on with it. I'll mention a few of them. As bump version, which can be used to change the version number of your package in a more easy manner, instead of actually going through each files manually and changing the version number there. And sometimes you will miss changing the version number in one file, and that can lead to trouble. Instead of that, you can just use bump version to change the version number. I think it uses semantic versioning, and that is a good thing. And there's pre-commit, which can be used to run any script or command before actually any commit is done. And there's ISO, which can be used to arrange your import statements in an alphabetical order. And there's cookie cutter. Cookie cutter is especially useful, and if you're using setup tools, because if you're using setup tools to package, you'll have a lot of files lying around, and you can use a cookie cutter template to generate all those files instead of creating all of them, and maybe you would miss it. So, and cookie cutter is not just for Python. There are a lot of templates available, but it is quite useful if you're using setup tools, among other things. So, what can we expect packaging to go from here? Well, the PyProject.toml file can become the center point over which the Python package evolves. Some proposals have been made, like a PEP 517 and 518, to allow to specify the build backend in the PyProject.toml file. And discussions and proposals are ongoing to like these 621 and 631, which will allow us to specify more the project basic metadata in the PyProject.toml file as a basic section itself, instead of being inside the section of another tool. What is going on to achieve that? And maybe, in all probability, we can expect a TOML module to be included in the standard library of Python, because we would need to parse a lot of TOML files, and it sounds logical to have a TOML module installed in the standard library, especially since we already have a JSON module, though we don't have a YAML module in the standard library yet, but yeah. So to wrap it up, let's see what we saw so far, right? So we talked about linting and styling, for which we can use pylint, flake8, and all. Then we talked about static type checking, bytecode identification, testing with PyTest, coverage with coverage.py, running tests automatically with docs, and packaging and publishing. So that's it. Let me see, how much time do we have left? Do we have?
We got 4 minutes for the talks and 5 minutes for the Q&A session. Okay, then.
Okay, if there's more time, I would be willing to, I would had a small demo to show you.
Yeah, sure.
Let me
Please go ahead.
Oh, okay, all right, thanks. Can you see my screen?
Yep, we can.
Yeah.
I've shared it.
Yeah. So remember that strcmp file, function that I showed you earlier? I made this tiny package in here. Just that function and just that test message. But before seeing the contents of
Hi, Julin. Sorry, your voice is breaking up. We're losing you. Hello, Julin. Are you there?
system, and the build backend that needs to be used to, that was used to build this project was setup build. And I have mentioned that the voucher, I'm using voucher for the identification here, and specify that I'm using a whitelist. I'll tell you what a whitelist is in a minute. This is a whitelist, because what contains that I have a function here is that I have not used. The lag space is meant to be used by the other people, by the user, so the complaint can safely be ignored. So I'm installing, and so I'm specifying it in a whitelist file, so that voucher won't complain about that. Okay. All right. Let's have a look at the setup.py file. The setup.py file, I have mentioned the name of the package, which I have named pack strcmp, to stand for package of strcmp. I mentioned the version number, a description, and similar stuff. Some draw classifiers, as well. And I've specified that I need at least 3.6 Python version in order for this project to, in order for the package to work. Okay. So this will be familiar, I think. Yeah. I named it more strcmp to sample module for strcmp. This is the only file in this package, and it just has that strcmp file that we saw many times during the presentation. So that's it. And then there's the test, which is same as the one that we saw earlier, the chicken egg example, remember? All right, and let's see the talks configuration file. I'm asking talks to run the test on Python 3.6, 3.7 for date, 9, and 5.3. And I have environments for router, MyPy, island, and storage. Oh well, I have not used this one. I'm not using it right now. Okay. So Python run like this, dictate run. These are the commands that I used for all those tests. And here run coverage. And I am asking to return false and say that it failed if the coverage is less than 100%. But you can modify that as you like, of course. So let's see if our talks is still running. It has
Julin, we're sorry. I think we're losing him due to connection issue. We'll wait him for a few minutes until 14:35, and then we will end this session. Let me chat him in the Discord room. We're sorry for the inconveniences. Please wait. Well, I have called him, chat him, but I still haven't got the answer. So we're still waiting for him until around 14:35. So it's an interesting topic from Julin Shaji. We learned about how to create well-formed package, and we learned how to lint the code, and then there's code automation and code coverage and code publishing and many more. That was a really good talk, but unfortunately, Julian cannot join here with us because of the connection issue. So we will wrap up the. Oh, great. He's here.
sorry I missed.
Hi,
Dropped out in
hello.
between.
Okay. Can we
All right.
now go to a Q&A session?
Yeah, sure.
Okay. So there was a really great talk about how to create well-published, well-formed package. We learn how to lint. We learn how to automatically test our package. But our audiences got questions. The first is from uh, Eka Kurniawan. PyTest is something new to me and seems cool. Do you have any advice on the transition from unit test to PyTest?
Well, yeah, I think it should be quite easy actually. If you're if you're already using unit test, you would be more than it would be too easy actually for you to move to PyTest. I think PyTest, the project website itself has a section on transitioning from unit test to PyTest. And of course, if you are already using unit test, it would be quite easy for you to move to PyTest because PyTest is a lot more simpler and straightforward. So if you are happy with using unit test, it would be definitely be better off. It would be easy for you to use PyTest. Yeah.
Okay, Eka, so if you are familiar with unit test, then it's okay for you to use unit test. But if you really want to try test PyTest, then it will be easier for you to try PyTest. Is that what you're saying, Julin?
Yeah, yeah, of course, yeah,
Because PyTest is more
yeah,
simple. It's simpler than
yeah. It's
unit
simpler.
test.
It's more
Hmm.
straightforward. Yeah.
Okay, and then the second question, which is our last question for this session. If guideline is not a rule, then how far should we adhere to it? From Lucia Yonarida.
Well, I think it's a question of using good judgment. If you're not sure
Oh,
yourself, if you're not sure yourself, maybe going to some online forum, or if you have some experienced people in it with that you know, asking them would probably a good idea if you're not sure yourself. And I mean, you make exceptions only in the very special cases, like the one I
mm-hmm.
mentioned. You shouldn't be making it all the time, otherwise you'll be going away from your coding style, and that's not a good idea. Yeah,
Okay. So, Lucia, you can go to the community. Maybe if you encounter that special occasion when you're confused whether to follow the guidelines or not, and the community will always be there for you, the Python
yeah, of
community.
course. That's the best thing about Python, right? There's
Yeah,
always someone around to help you out, and a lot of people, very friendly people.
yeah, the community is strong together.
Yeah,
Okay, Julian, what an awesome session, but unfortunately we ran out of time. Thank
yeah,
you so
right.
much, Julin Shaji, and also for all audiences who participate in this session. Allow me to close this session, and we also have break and networking session quiz in the main stage. So after this session, you can go to main stage to enjoy the session. Thank you again for Julin Saji and for everyone. See you in the next session.
Bye. Thank you.
Bye.